Now I would like to ask Larisa Yurievna to make a presentation on some aspects of use of optical and radio space data.
Good afternoon. I represent the Department of Geoinformational Technologies of VNIIGAZ, and we are processing. And we've been doing the this geospatial data, and I'd like to share with you some of our results of our work. In fact, the Yamal Peninsula and the neighboring areas among the few resource base of Russia for carbohydrates. Now, a number of deposits have been explored already, others are planned for exploration, and now more than 30 deposits have been explored. It's been attached to the main pipelines, and this summer they started to the industrial exploration of this area. The whole area of Yamal Peninsula is characterized by very difficult climatic conditions. And also, it's very hard. It has a very difficult terrain, which makes it extremely difficult to do and to use remote sensing data for this area. The area, the result of study of which is shown in this presentation, is highlighted in red, and you can see it's far away to the north. And the first aspect which we would like to share with you is the application of optical spaceborne images. And just like many other reporters, for that we used the space images of WorldView-2, which allows us to do land surveys and build the maps, metric maps. And this is the space image which was kindly provided by Hitachi Solutions to us. And this is the area of Yamal. And you can see the elements of pipeline infrastructure, the square white patterns here. The bathymetrical estimation was done in accordance with Bouguer-Lambert formula after the atmospheric correction, and due to the physical characteristics, it should be the edge blue channel which should have the highest penetration potential, but because of the turbidity in water, its penetration capacity is dropping fast, and its spectral band is also consumed by chlorophyll or phytoplankton, and we can use it only for very clean, organically clean waters. Unfortunately, for that part of the world, it wasn't possible to do. On this slide, you can see the acquired map in the area of Yamal Peninsula. The acquired depths shown here are not absolute measures. They can be recalculated based on the absolute measurement, but for that we need to know such parameters as the tide in and tide out, and also we need a very detailed elevation model, and we don't have this information. That's why we can do the measurement, but we didn't have need for absolute measurement of depths. And the most important thing that we had to study was the feasibility study of a pipeline project, and to see in what way different parameters change. If compared to the size and dimension of the pipelines, and location or positioning of such sites allows us to analyze similar surveys, which are quite expensive because This is a remote area prone to ice locking and storms. The next thing was the application of radar space images for our service. We use some amplitude data for radar analysis. This work was done within the framework of the design of geodynamic section, and for that purposes we use the data of TerraSAR-X and geodynamic testing area allows us to do the hydrological observations. So for that, each site needs to have a network of hydrological stations, and this area had such stations. And on this slide, you can see that unfortunately it occupies small area compared to the total area of which was analyzed because of the difficulties of the climate and transport inaccessibility. And it is considered that the surveys on such a small area, we build models which then cover the whole area of the deposit, and we wanted to test whether we could use the TerraSAR-X data for hydrological purposes. In order to do this, we had to use radar data scanned when the surface would be free of snow. Why? Because depending on the type of snow, the radar data shows it up differently. That is why for the selection of radar data, we use meteorological data from meteorological stations closest to this area. That would be Marisal meteorological station. The meteorological data itself was acquired through the system of open exchange of meteorological data on the sites which are shown on the screen. In the table you can see the example of data that you can find and retrieve from the site. The most interesting for us was the size of snow cover and its status. As a result, based on the available radar data from 2008 until fall of 2008, we have selected a set of images which by the time of taking these images there was no snow cover. In terms of amplitude evaluation, we managed to build interferograms for this area to study the elevation fluctuation. It proved to be impossible because in summertime there is a great variability and there's no coherence here. You can even see it in the lakes. You see the dimensions change a lot throughout a short period of time. So we can consider that dark and smooth images, the darker, the more flat and wet and reflective the surface is. The lighter the surface, the more inundated and serrated it is. Based on this, we have identified a number of intermediary planes. You can see them on this slide. Here the color denotes the dark water areas and also some structure elements as roads and pipelines. And you can see that in many time periods infrastructure could be inundated. Also the quiet results based on the amplitude portion classification fully coincide with the maps which were built by the State Meteorological Institute based on their study and research. And on this slide you can see some of the examples of such classification. The pink color shows the contours. You can see some of the water reservoirs and lakes can flood the area. And what can I note is that the acquired data shows the real dynamic of the changing status of this surface, and they do not really depend on the success or lack of success of the model which is used for calculation of this forecasts. And the results of our research can be used for the analysis and forecast of flood situation and for the analysis of possible emergency situations and the infrastructure sites. Thank you.
Поблагодарим за замечательный.
I think now we can thank our speaker for a very good report, because as long as we have run out of time, we'll be able to ask all the questions later on. And now I'll give the floor to